Now let's move forward to the next topic, which is the approximation using tangent line. We know for a fact that calculators are not really available for us anytime. For example, if you're out there buying something and you don't bring your calculator with you unless you have your bag, of course. So maybe this method would be working for you, but in general, why would you think of something like doing the derivative just to get the price of that certain item that you buy? But anyway, for the sake of this syllabus and mathematics, let's understand how this approximation using tangent line works. Now, this topic works, or this line works, in the same way that we use this Newton's approximation. It's just that we have this equation which states that the tangent line equation, this y sub t, is equal to f of c, meaning if you have c that is a certain value at the function, let's say the value of x, and then you substitute that value with the given function, so that's f of c, and then you take the derivative and then substitute that value again and then multiply that with x minus c, which in this case c is a constant. So you'll be able to get the equation of the tangent line. Now to illustrate this in a Cartesian coordinate plane, so if you have something like this, and then you need to find the value of y when x is this value, let's say x is equal to c in this case. So you need to find this. Now if you're not able to find the value of y because of some problem, then you can just take the tangent line here and then use this tangent line equation to obtain the value of y using this value of x. That's the idea of tangent line approximation. And now let's try solving for that using this problem. This tangent line equation gives us y squared is equal to x squared minus 6x plus 4 at x equals 7. Now if we're just looking for the value of y from this equation, we can just simply substitute 7 from this equation and find the value of y. With this, we know that y is equal to 7 squared minus 6 times 7 plus 4, and then you take the square root because this one is square. So you'll be able to get a value of y is equal to plus or minus square root of 11. And in this way, this is already your answer. And for the second one, you already have the answer because that's the value. But that is, of course, using your direct substitution with the equation. And for the sake of this problem, we'll try a different method. We'll be using the tangent line approximation to solve for the value of y. So from this equation, we know that we need to find f of c. And that is done by substituting the value of x at the equation. And we know that we can rewrite this equation in terms of y is equal to the square root of x squared minus 6x plus 4. And in this case, that's positive, negative. So if you try to substitute 7 from this, we know that f of z, which is actually equal to f of 7, that is equal to positive or negative square root of 11. So in this case, that's positive or negative square root of 11. But in this case, we need to find the derivative of c. I mean the derivative of f of x or y. So in this case, let's find the derivative. So we have y prime, or that is equal to f prime of x, that is equal to 1/2. And then we have x squared minus 6x plus 4. We raise this to negative 1/2. And then we multiply this with the derivative of the function. So that's 2x. And then minus 6. We can also factor out 2 from here. So I'll be able to get y prime, that is equal to x squared minus 6x plus 4, and then raised to negative 1/2, and then this one is x minus 3. So I factored out 2 and then cancel this for the 1/2. So this is basically the derivative of our y, and then we need to substitute 7 to this derivative. So if we do that, then we have f prime of 7, that is equal to 7 squared minus 6 times 7 plus 4. We raise that to negative 1/2, and then we have 7 minus 3. And we know for a fact that this is 11, so if we need to take the square root of that, 1 over the square root of that, so we know that f prime of 7 is actually equal to 4 over the square root of 11. That's positive, negative. Okay, so this is our value for f prime of c. So we do have this f of c, we do have this f prime of c, and then we add this x minus c, or we multiply that to f prime of c, that's x minus c. So that's x minus 7. And finally, we'll be able to get the tangent line equation, which is y sub t, that's equal to f of c, that's positive negative square root of 11. And then we add this f prime of c, which is positive negative 4 over square root of 11. And then we multiply this with x minus c, which is 7. So this is our answer for this problem. And as you can see here, we've obtained the same answer. Now if you try to substitute this value 7 to the tangent line equation, that's 7, and then this will be 0, and then we're left with positive negative square root of 11, which conforms to the fact that we've obtained this value based on direct substitution. So in this way, we've already understood that the approximation is actually very accurate in this case. Okay, so now let's try number 2 in this sheet. So we need to find the value, the equation of the tangent line. So this is the line at x equals a being differentiable at this value, because it is very important to emphasize that the equation should be differentiable at a certain point or letter a, c, because if it's not, then we can't find actually the derivative of that in that point. So it must be specified that it should be differentiable when we don't give any constant value like number. So the first thing that we need to do here is to find f of a. So taking that from the equation, so we have f of a, that's equal to 1 over a minus a squared, and then plus 2a. And that's our f of a. Now we need to differentiate this equation so that we'll be able to get f prime of a. So y prime is equal to negative x raised to negative 2, and then we have minus 2x plus 0, because 2a is a constant in this case. So we do have f prime of a, that is equal to negative a raised to negative 2 minus 2a. So basically this is our, we can also rewrite this as 1 or negative 1 over a squared minus 2a. Okay, so in this way, we don't have any negative exponent, but this will do. Okay, so finally, the equation of the tangent line is, you copy this, this one, f of a, so that's 1 over a minus a squared plus 2a, and then you add the f prime of a, which is negative 1 over a squared minus 2a, and then you multiply this with x minus c. So in this case, c is equal to a, so that's x minus a. So this is simply the equation of the line. So we can now try to redefine this or rewrite in a way that it looks like this. So I'll factor out 1 over a. So in this case, I'm left with 1 and then minus a cubed, because I factored out 1 over a, and then this one becomes 2a squared. And then we add, so in this case, adding the negatives here, I can factor out minus 1, so that's negative, and then we're left with 1 over a squared plus 2, and then quantity x minus a. We can also redefine this, so we have 1 over a, and then rewrite. So finally, what we'll be getting is, this is the LCD, so we have 2a squared, and then plus 1. Should be 2a, that's why we have 2a cubed here. And then we have a squared, and then x minus a. Okay? So finally, we'll be able to get the same answer as this one. Okay, so that's it for our tangent line approximation. And this is a very easy topic. You just have to find the derivative, and then the values of the derivative, as well as its value, given that you have the value at a point, let's say a or c, or any value, real valued number. And then you just have to plug in those values from our general equation, which is this y sub t is equal to f of z plus f prime c, and then x minus c. Now the difference between this approximation using tangent line and then this Newton's method is that in Newton's method, we're actually finding the zero of a function obtained from the first reference point that we set. But in this tangent line approximation, we're actually finding the value of y at any given point using a tangent line that we usually set based on the value of our domain. So that's the difference from the two. So you can just interchange them in a way that, oh, I'll be using this because this is what I want. If it's looking for the zero, then the best thing that you should be using is this Newton's method. But you can also use this for the zero. It's just that you set this y sub t is equal to 0 in that case. But the thing is, we're much more concerned with the value of y in the equation rather than finding the zero for tangent line approximation. Okay, so that's it for this tangent line approximation.